Hey, welcome to the first of the Little Guys series of desk casts. I'm Tom Gunderson with the Little Guys, and this is my desk, and we're going to do a series of these videos in the next few weeks and months coming up about some topics here and there. We're also going to be reviving the live show at some point. We're going to work on rebuilding the studios and the new offices here at the Little Guys, which you can come see us at 9700 197th Street in Mokina. It is about a mile and a half south of I-80 on LaGrange Road. We are on the west side. Just LaGrange Road south to 197th Street, take a right, and we are right there. Can't miss us. Got a pretty easy to see location. You can also always check in with us at thelittleguys.com, Facebook at thelittleguys. We don't do a lot of twittering, so you can certainly sign up to follow us there, but we don't really do a whole lot of tweeting. Maybe we'll change that at some point. You can also email us, info@littleguys.com. We will get you that information again later on in the presentation. So today we're going to focus on Wi-Fi. Networks are important. We do a lot of work with networks. We always ask the question when we go and visit a site, a location or a business, how is the network? And the reason why we ask the question is because a lot of the stuff that we do requires the network to be good for it to function properly. If the network doesn't work, our stuff doesn't work. And that could be AV gear, it could be control gear, it could be live streaming gear like what you're seeing going on now. So it's very important that this works, the network works. And it's a huge topic. We can go into a lot of different parts of it. Today we're going to focus particularly on Wi-Fi, because you are being barraged with Wi-Fi information out there that may or may not be accurate and may or may not help you. And I'm going to guess that some of you watching this have tried a lot of the solutions that are out there that don't necessarily fix the problem. So the majority of this desk cast is going to be education, as best as I can do it for you. Try and make it easy to understand the basic concepts. Obviously there's way more in-depth components to it, but this is what we're going to focus on to try and make it easy to you'll understand what's going on and maybe help you solve the problem, and also see what the right solution is, and you'll be surprised how simple the right solution is. So we're going to get this going here, and we're going to make a couple quick changes to our view. Take me out of the picture. Again, this is the Little Guys, first in our series of desk casts. Let's talk about your Wi-Fi. So we all recognize that logo on the left. It's your Wi-Fi indicator, and it doesn't matter what platform you're on, they pretty much all look somewhat like that. And when you have all your bars, you typically have fast download speeds. That's the whole thing, right? You want to see you have the bars, that way you know you're going to have the fastest Wi-Fi speeds. However, and then when you have less bars, your speeds are slower. It's a pretty simple gauge, and you see that on there, and it kind of gives you some confidence that maybe what you're doing is the right thing. But wait a second, sometimes we have all the Wi-Fi bars and our speeds are still slow. Well, now that doesn't make any sense. How can that possibly be? Well, we're going to address that. We're going to talk about how and why that happens, and again, we'll get to the solution to how to fix it towards the end here. So let's start with our bars. What makes our full signal turn into our weak signal? What causes the Wi-Fi to get weak? Alright, well, there's a couple of factors, a couple primary factors that we deal with on a regular basis. The first is how far away we are from your Wi-Fi access point. When I say access point, that is whatever the device is that creates your Wi-Fi. For many, it might be the combination modem router Wi-Fi piece you get from your internet provider. Doesn't matter who it is, they all will provide you with one if you don't have your own. For others of you who've tried other solutions, we'll talk about specifically, but whatever the piece of electronics is that is creating your Wi-Fi, the further you get away from it, the weaker it's going to be. That's just the way it works. There's no getting around that. The signal doesn't travel forever. and that is one of the reasons why your Wi-Fi will get weaker. we're going to throw in a little turn and twist here, and maybe you've noticed, especially if you've bought your own or one of your providers have put in, and you see sometimes you have two different Wi-Fi networks. Sometimes the box just says it does both Wi-Fi bands, quote unquote, BANDS bands. Well, that's because there's two Wi-Fi sets of frequencies we get to use, and one is on 2.4. That's been around the longest for us to use, and the most legacy equipment will have that. Just about anything Wi-Fi will be able to do 2.4. The other one is 5 gigahertz, so it's a higher frequency. Now we'll talk about how that relates to distance first. So 2.4 will actually travel further than 5 gigahertz will. As you can see in our hopefully simple to understand graphic here, the signal will be equally strong when you're right next to your access point, but as you get further away, the 5 gigahertz signal will drop off faster than the 2.4. I'm not going to assign any kind of percentages there, because if I say it's half as much, then somebody's going to say, oh no, it's not half, it's 2/3. Or listen, there's a lot of factors that go into it, but the general premise is your 5 gigahertz does not go as far as your 2.4. The other thing that affects your signal are walls, barriers, doors, just any kind of materials the signal has to pass through. So if your Wi-Fi router is in the office and your TV room is 2-3 rooms away and it's got to pass through a couple of partition walls, well, every time it passes through some sort of a surface, it's going to reduce the Wi-Fi strength. And that even includes glass. You think you can see through it, it's going to be fine. Well, no, a lot of glass has metallic component and things inside of it that will also attenuate. Maybe not as bad as what a full-blown wall. And the wall materials make a difference. You know, a more basic, newer construction home with just a simple half-inch layer of drywall and maybe no insulation, that's not going to attenuate nearly as bad as, let's say, a 100-year-old house with plaster and lath, and even worse when the lath is metal. The metallic part of the lath will just block those frequencies from getting through. It's true for all radio signals, but especially at these frequencies, it really makes a difference. So this is the other major component of what makes your Wi-Fi get weaker. How far away from it is one, and how many things it needs to pass through, surfaces or barriers it needs to pass through. So you can see in this logo, when I don't have anything in between it, it's going to pass better. You're going to have less reduction. It'll just be limited by your distance. Now, this little triangle graphic, I'm going to use this throughout the rest of the presentation in different forms and factors. I try to use this to illustrate two things. On the left side, where we are green and it is the tallest, the height is going to represent how strong your signal is, and the green is going to represent how fast your signal is. So green's good. Full green, we got our full speed, and full height, we're at our full strength. We're going to transition to the right, and you'll see as the signal gets weaker or the triangle gets smaller, the speeds get slower, hence the red light. You get to the red light, you got to stop. You get into red lights in traffic, you're slowed down, right? So that's why we use the green and the red for our graphics here. Hopefully this makes it easier to understand some of these slides. So we're looking for as tall of a triangle as possible and as green as possible. That's our best signal. When it gets down to that fine point and it's red, that's going to be our slowest and weakest signal. The other thing about that is that as your signal gets weaker, it is going to be slower. There's just no way around that. Your speed does not maintain full speed throughout the signal no matter what it is. As the signal gets weaker, the speed's going to be slower. It's related. There's no way around that. Let's talk about speed. Now, sometimes you go out and you do some of your research and you buy the very best, highly recommended products there is. So let's just relate this to a sports car. So you go out and you found out this red sports car is the fastest sports car you can possibly get. It's going to do everything you want. It's going to handle the corners. It is what you want to have. You take that race car, sports car, and you put it on a wide open track, right? You got a wide open highway. You got your race car to drive in it and your sports car. Well, you get to go fast, and you are cruising, and you're having a good time, right? What happens if we take that same high performance car, vehicle, race car, sports car, whatever you want to call it, and we put it in city traffic. Well, guess what? It's gonna go slow. And that's going to relate here to how we're talking about Wi-Fi. Even when we buy the very best equipment, or we think we bought the best equipment, the truth and the reality of Wi-Fi is, and we talked about it, we have two sets of frequencies we get to use. And guess what? All of us share them. So when you get into areas where there are a lot of people using Wi-Fi, we are all sharing the same highway. Well, it's rush hour traffic. We're in Chicago. Most of you have probably traversed one of the major expressways. Let's just talk about the Dan Ryan. We're on the south side. You know, you take the Dan Ryan on a Sunday morning, typically, it's pretty wide open and we can get up to the city pretty quickly. You know, it's not bad. You hop on that Dan Ryan at 5 o'clock on a Monday afternoon, well, you're doubling, tripling your travel time, or worse. Oh, hopefully not worse, but it does happen. Nothing changed. You're driving the same car. The highway is the same, but everybody's trying to use it. Well, your Wi-Fi is the same way. You can have great equipment, and we have the highway to drive on, but when everybody wants to get on, well, that's going to affect it. So that may explain why sometimes you're going to have slower speeds. Let's just say in the evening, if you live in a really congested urban area. It doesn't necessarily have to mean the city, although the city is the worst. When you have, let's just say you're in a 500 unit condo or apartment building and you're all stacked on top of each other, yeah, your Wi-Fi's are you're not gonna have clear sailing a lot of the time, and when everybody's home, it's going to slow it down even more. So that is one factor, unfortunately, that is out of your control. But you just need to understand that that's what it is. Now, some people will say, well, when I run into this, I want a solution to get past all this. So they're going to go out and they're going to find something like this. I'll just run over all the traffic. Well, it doesn't quite work that way. And you will see sometimes people will advertise that they have the newest Wi-Fi access point or router, and it's the ultra high power, so it'll get you through better. Well, that's really not true. First of all, there are rules. In fact, the majority of Wi-Fi access points are all pretty close to the same rated power because the FCC has set a maximum power level, and nobody really makes them less than that these days. There's a few miles that are save you a few dollars and maybe a little bit weaker, but for the most part, the signal strength off them is the same, and your devices are only so strong, and the communication goes both ways. So if you had a really loud transmitter and a really weak receiver, well, it's not going to work. Maybe a better visualization is you put somebody across the football field and you give him a megaphone and he yells to you through the megaphone. You can hear him just fine. You reply back with no megaphone, he can't hear you at all. Well, that's the same thing with if you had an ultra high power access point, well, your phone or your tablet is not an ultra high power tablet versus a regular power tablet. It's all the same, and it needs to be both directions. So yeah, we can't go out and buy a monster truck to get through traffic. The same with we can't buy a monster signal to get through the Wi-Fi congestion. You're just going to have to deal with it, and there are things we can do to get around some of it and set up things properly. That's more in the back end for a professional to do, like the little guys, where we can actually scan the area and look for clear Wi-Fi channels to maybe move you over to, or do some other creative things, or some of the Wi-Fi systems will actually auto scan for you. So there are ways to help with it, but there's never a 100% solution to it. Okay, well, we're going to go with this next slide. We learned that the further we get away, the weaker the signal is going to be, and the weaker the signal is going to be, the slower it's going to get. So let's just take this scenario. So my device, let's see, my access point's there on the left. Let's just say that's down in the office, or maybe the TV room, wherever it might be, and your phone's up in a bedroom or out in the garage or somewhere secondary, and you're just far enough away that you're not quite getting much signal, and of course the speeds are really slow. So we see this a lot. We have seen more of these than we would prefer to see. And we see a lot of people recommend this is the solution to all of your problems. This is a very simple, easy solution. And it is called the Wi-Fi range extender or Wi-Fi repeater. So this is a device that is completely wireless. And as you can see, you would just take and plug it in to an outlet. The goal is to plug it into an outlet where you're, to extend your range. So what do? Well, my bedroom has weak signal. I need to make it stronger. So I go buy one of these, and they range in price. I've seen them for $15, $20 up to $100, $200, depends. They're all, whether some are better or worse, I'll let you be the judge of that. But this is the general premise, that it'll take your signal coming in and it re-amplifies it and gives you all your bars back again. Now, the reality is that actually does happen. You plug this in, and then when you buy this, you will have all of your bars. So let's zoom in just a little bit. Our signal comes in, we plug this in right here. It re-amplifies our signal out. And we see the weaker signal comes in and it makes it strong again. That is the premise of the Wi-Fi range extender or Wi-Fi repeater. Again, wireless. Just plug it into an outlet somewhere. You can see there's a couple antennas on it. I'm not picking on that particular model. It's just a nice image I found for you. So there's a lot of them out there. Lots of them out there. Some you don't have the antennas. You can see they're just little boxes. But they all are basically the same thing. Let's discuss what really happens. We take our device, we have our signal coming in. Now I'm going to add some numbers here to make this more quantifiable to you. Maybe makes a little more sense. Let's just say our Wi-Fi was 100 megabits in speed, where it was the strongest. Now we talked about, as it gets weaker, it gets slower. So maybe at the far end, in the red area, we're only getting 10 megabits pass through. Okay? Well, there's a dirty little secret here about Wi-Fi range extenders. The single band ones can never deliver whatever speed it's getting. It can't do it because it's repeating the signal. And when you repeat the signal, you cut your bandwidth in half because it has to listen half the time and talk half the time. Can't do both simultaneously. So that 10 is now cut into 5. That's your best case scenario on this graphic, is that your range extender is going to have an output of 5 megabits. Half of what it was getting in, which was only 10% of the original in the first place. And now we're down to 5% of the original speed coming out of this. And of course, by the time you're into the weak area of the range extender, who knows if you're getting anything at all, what it might be. But if we look at your signal bars, you think you did the right thing because you have all your bars. Well, guess what? This is the scenario of your full bars give you slow speeds. How we talked about when we first opened this little podcast. The scenario of I have all the Wi-Fi bars and it's still incredibly slow. This is probably the single biggest culprit right here. Now congestion can do this too a little bit, but more often than not, this is the biggest issue that causes this scenario. Wi-Fi range extender only can give you half of what it gets. You're plugging it in an area where the signal is weak. Right? Now if you moved it closer to the other one, you might be able to bump that number up. But now you're buying more range extenders and amplifying, and it's still cutting. This is not a good solution, and henceforth is not a good investment of your money, because we've walked into a lot of homes where we might find 4, 5, 6, 7 of these around the house, and some even unplugged laying on the floor next to another one plugged in because they tried a different brand. They spent hundreds and hundreds of dollars, if not more, on a solution that didn't solve the problem. So let's remember that as we move on with this show. The Wi-Fi range extender is not a good solution to make your Wi-Fi better. Well, blank slate here. There's another new trend on the market. It's what we call a mesh system. So again, I'm not picking this particular brand, but what we're seeing here is what they call a mesh system. Your Google Homes, your Orbeez, and now you hear the Comcast X5 commercials. These are all what we call a mesh system. And it's different than a Wi-Fi range extender. And in theory, it's better than a Wi-Fi range extender. We won't deny that. Still not the best solution. But what's happening here is now you're locating these extenders, and they're still wireless, around the house, so you can have your better, stronger signal bars all around the house in the different areas, okay, because you're putting yourself closer to the access points, which is what you want to do to keep your signal strength up, to keep your speed as high as possible. And then these devices all talk to each other wirelessly, and they create what they call a mesh. And the more you add in, the more they can link together, and the more they can create kind of a blanket of coverage. So that being said, let's talk about what's really happening with this kind of type of a system and why it may or may not be the best solution for you. That lightning bolt you saw, well, what is that? How are they talking to each other wirelessly? There's got to be a way. Well, there is. Let's refer back to our slide real quick of the 2.4 and the 5, and further away we get away, and the fact that we have two bands, right? Now that we know that, I'm going to tell you that the majority of the mesh systems, what they're doing is they're using one band, usually the 5 gigahertz band, for their links to talk to each other, and using the other band for your device. Now that's actually okay on a grand view, because that means, unlike a range extender, which will have to cut your bandwidth in half, they won't be cutting your bandwidth in half because it's not using the same frequencies. It can actually transmit on both channels at the same time. It can do that. It's two different radios. So it can simultaneously stream that information between the two bands. It kind of creates a bridge or a link between them. And again, most of the systems out there today are using the 5 gigahertz band to link between their devices, and then 2.4 gigahertz band to then connect to your device and deliver your Wi-Fi. You're thinking to yourself, well, that's not a bad solution. That's not bad. Yeah, maybe I got to locate a few of these closer so they can have a good signal between them on the 5 gigahertz, but then 2.4 travels further, so I'm in pretty good shape. Maybe I'll have good signals around. Well, let's get a little further into that. I'm going to modify the triangle here, and what's happening is the reason why we had the new band of 5 gigahertz introduced, this is years back now, it has the ability to deliver higher Wi-Fi speeds than 2.4. So while 2.4 can go further, 5 can be much faster. Much faster. Quite a bit faster, actually. In fact, if you want to deliver today's broadband speeds at all, you're not going to do it on 2.4. It's just not, it can't do it. It will not get that fast. There are some solutions. A single channel is only going to give you 54 megabit on a theoretical perfect. Now there's some schemes out there to blend some channels and get a little higher speeds, but 2.4 is not going to get you your high speeds. 5 gigahertz is where you want to be. All your new devices are going to have what they call AC technology in them, and that's going to be on 5 gigahertz for delivering the maximum speeds. So if you're paying for a 300 megabit Comcast connection and you want to get it wirelessly, which it is possible, it's not going to happen on 2.4. It has to be on 5. All right? So, while the range of 2.4 is better, the speed of 5 is better. Okay? Knowing that, let's go back to talking about the lightning bolt, the links between your mesh system. Reiterate, 5 gigahertz Wi-Fi, shorter range, much faster. Let's put that in play with our mesh system. Well, ta-da, those lightning bolts are actually 5 gigahertz links, which means they're hogging the one you want to use for their devices. And you're stuck with the old one for your devices, which means you're not going to get the fastest speeds possible, or probably nowhere near what you're paying for coming into your home or your business through the mesh system. It's just not going to be able to deliver it. It is a better solution than a Wi-Fi range extender, but it is still not the ideal or best solution. Now, why is everybody approaching this? And you see a lot of marketing on this, and you know, Comcast is just barraging you with commercials about this. Well, it is very easy to deploy. It doesn't take heavy technical skills to go walk and plug in more boxes around a house. Anywhere you find the signal might be a little bit lackluster, right? So this is not great. There's also another disadvantage. This whole traffic thing, well, the more I'm piling these things in my house, and the more I'm going to be clogging up all the lanes of traffic that are possible, I'm going to be slowing myself down. Now, on a side note, and this is not part of this podcast, but I'm going to just put it out there, we will tell you that a lot of the mesh systems are not approved by a lot of the control manufacturers out there, simply because they do a lot of extra communicating between each other, and it creates a lot of traffic, and it can create a lot of network congestion, and also some other weird anomalies. And control systems and some AV type streaming devices have a really hard time with that, and it creates issues. So you're going to find a lot of these systems are now being put on what they call blacklists of equipment, which means the manufacturers will not support the equipment if you're using one of these for your network to deliver your Wi-Fi around the house or your network around the house. So just be aware of that. I'm not saying these never solve an issue or cannot be somewhat usable. There are certainly times where deployed correctly and your expectations are managed, that it couldn't be successful for you and do what you want it to do. But I'm firmly standing behind the fact that it is not the best solution. It is certainly not the way to get the best speeds of what you want to have around the house. So, all that being said, that was a pretty good education, I think, on the big chunks and basics of Wi-Fi and why things are and aren't. What is the best solution? It's actually quite simple. You have a network. You have a hardwired network somewhere in your house. It may just be the hardwire coming from your provider to that first wireless router. So there's a hardwire there. The best solution is to locate access points around the house and hardwire them. The hardwire doesn't suffer the limitations of Wi-Fi. It's your own personal superhighway with no extra traffic from any neighbors. Right? It is the only person driving that highway is you, and you are hard pressed in any type of typical home situation, and even a lot of business situations of a small business, to try and tax the bandwidth available on a good Cat 6 network or Cat 7 network like these days. There is a lot of bandwidth there, and your Wi-Fi is not going to exceed it. This is the way to do it properly, because what this will do is this will ensure every access point can deliver the fullest speeds on either band, especially if we use access points that are what they call dual band. So you have both strong Wi-Fi and fast Wi-Fi everywhere around the home. And a quick side note to this, sometimes what we'll see is people trying to implement this themselves they go and buy 2 or 3 additional wireless routers, and they put in the same wireless network name and password to kind of create this. Well, that doesn't do the same thing as what they call a managed Wi-Fi network. So if we're going to do this, we've got to do it with the right equipment, equipment that is talking to each other so that it'll hand you off to the strongest point. I probably should have made a slide about this, but we'll just talk about it briefly. If you just use regular access points that don't communicate with each other, or if you go out and buy 2 or 3 extra wireless routers, and I've actually seen providers do this where they'll put an additional modem somewhere else in the house. The problem with that is your device will hang on to a signal until it loses it. So you may be sitting next to a device, but if you connect it to the one across the house first and you haven't completely lost your signal, you're going to be stuck on that one, and it's still going to be slow even though you're right next to one where you should be fast. A good managed Wi-Fi network like this, hardwired, where as you get closer to different access points, it says, oh, you're stronger here, I'm going to flip you over to this point. That is the way to do this. This is the way to solve this and create it. And I will tell you that this exists. It is not super expensive to do. It's not really rocket science to do. There's very few times we cannot find a way to get a cable somewhere. There are some other solutions where we may be able to use an existing coax as a network line. But Cat 6, Cat 5 at a very minimum, Cat 7, if we really want to do it right, is the way to go. And locate these around the house. If you're building a new house, let me say it again, if you are building a new house, you should be putting in some wiring, besides for hardwired network. We'll do another desk cast about why we want to use hardwired versus Wi-Fi. But you want to locate some wires around the house to put some wireless access points, because you're going to want to have good Wi-Fi everywhere. And while the walls are open, it's a really good time to do that. It's a lot less expensive to do it then, because the labor is cheaper, since there's no fishing of walls and things like that. And you know you're going to be covered for the future. You're not going to be using less Wi-Fi going forward. Let's agree to that. You're going to be using it more and more. And if you put the infrastructure in place, you can have really good Wi-Fi to enjoy. All right. Well, I hope this was somewhat educational for you. We are out of time for this desk cast. Let me just go on and give you the information we talked about a little bit before. Again, the little guys, you can call us 708-754-8844. You can email us info@thelittleguys.com. You can check out the website www.thelittleguys.com. And you can also come and see us 9700 West 197th in Mokina. I-80, however you want to get onto it, and come south on LaGrange Road. And you're going to make a right turn on 197th Street. There's no stoplight or anything there. It's just a stop. It's a right turn only. So you got to pay attention for it a little bit, but you'll see it. It's marked, and then we are basically right there on your right when you make that turn. You can come and see us Monday through Friday, 9 until 5. We are here. If you want to come and talk to us another time, you can certainly call or email, and we can make appointments. What's probably best is call up, and we've got David, and we've got Ed, and we've got Steve here. They are more than willing and able to come out to your location, whether it's your home or your small business, to talk about these things with you right there. And sometimes that's the best. In fact, a lot of times that is the best. Let us come out and see what your situation is, so we can recommend the right solution to whatever it is, whether it's Wi-Fi, audio, video, control, home automation, lighting, blinds, shades, whatever it might be. We can help you with all that. So again, you can come and see us, or we can come and see you. Either way, we thank you for watching, and again, we will do some more of these coming up in the future, including some other shows coming up soon. Thanks.